Welcome to Base 8 and Base 16 numbers. We'll start off by counting in Base 8 and Base 16. Recall that in Base 10 there were 10 digits, 1 through 9 plus the 0 digit. So as you would expect in Base 8 there are 8 digits, 1 through 7 plus the 0 digit. To count in Base 8, you count through 1 through 7 normally, but then you run out of digits. So you take your 1's digit and you start over again with a 0. And then you carry a 1 over into the 8's position. So this would be 1 8 plus no 1's, which is the number 8. And I've written the Base 10 number system, our number system, right down the middle for reference for you. Okay, to go on to number 9 then, you'd say 8 plus 1. 10 is 8 plus 2, 1 8, 2 1's, etc. And finally you get yourself up to 17, which is 15 in the Base 10 system. And to go up to 18, well, you've run out of digits again. So you start over again at 0. You carry another 1 into the 8's position. So now that's 2 8's, no 1's. So that is 16. And then you continue on to 17, you add a 1, 18, you add another couple of 1's. And eventually you'll get up to 77. Now 77 is 7 eighths, which is 56, plus 7, which is 63. So I've shown it here as 63 Base 10. By the way, in Base 16, well, we'll talk about that in a second. To go to 64 then, you'd start over your 1's digit and carry, but this time when you carry, you're 1 more than 7, so we don't have an 8, so again we start over, and then we carry a 1 out. So this says 1 8 squared, which would be 64, plus no 8's, plus no 1's. So that is 64. Now in Base 16 we need 16 digits, and of course we run out at 10 because we only have 10 digits, 1 through 9 plus 0. So what we do to get up to 16 digits is we borrow 6 letters from the alphabet. So the 10 we'll call A, the 11 is B, the 12 is C, etc. up to F, which is 15. And so if you want to do 16, you have to start over again. So the F goes back to a 0 again, and you carry over 1 to the next position, just like you did with the 8's. And so 17, you'd add a 1, 18, you'd add a 2. This time when you get up to 63, you're at the number 3F. That's 3 16's, which is 48, plus F, which is 15, 48, and 15 is 63. And to go to the next digit, you have to start over again because F is your last digit. So you start over at 0, you carry another 1, so 64 is 40, 4 16's, plus no 1's, and that does give you 64. Now the next thing we want to do is change Base 8. This is a number Base 8. And this is a number Base 16, and we want to change those to Base 10, and we do it the same way we did with Base 2 numbers, but this time in the case of the 651 we're using Base 8. So that would be 6 8 squareds plus 5 eighths plus 1 8 to the 0, and so 6 8 squares would be 384. You might need a calculator to see that one. Plus 5 eighths would be 40. Plus 1 would get you up to 425 Base 10. Notice you need a bigger number, Base 8, 651, to equal a smaller number, 425, in Base 10. Let's talk about now changing how would you do a Base 16 to a Base 10. Exactly the same way. You just use the base of 16 instead of 8. So you'd have A 16 squareds plus C 16's plus 3 1's. And A 16 squareds, that's 10 256's, and C 16, well, C is a 12, so C16 would be 12 16's, which would be 192 plus 3. And when you put all that together, you get 2560 plus 192 plus 3, and that is 2755. Now let's do the more difficult transformation. That's when you take a base 10 number and change it back to a base 8. When we took a base 10 number and changed it to a base 2, we did repeated divisions by 2. And then we looked at the string of remainders left over. Here we'll do repeated divisions by 8. So I'll start off with 8 divided into 297, and I'll keep track of my remainders on the other side of that line. Well, 3/8 is 24, so 8 goes into 29 3 times, and 4 from 9 is 5, so 8 goes into 57 7 times, and there's a remainder of 1. Now we'll divide 8 into the 37. Well, 4 times 8 is 32, so 8 is going to go into 37 4 times. The 2 from 7 gives you 5, so you're going to have a remainder 5. And notice we're already to a number smaller than our base. So that's your signal to stop dividing. So if you write your digits out this way, you get 451. Base 8 is the same as 297 base 10. You don't need as big a number, base 10, to get equal to the number in base 8. Okay, let's try base 16. Now this time, I'm going to do this using a calculator and show you a short way to change these bases using a calculator. And you can do this on any base. You don't have to wait for base 16 to do this. But again, we're going to be dividing by 16 each time and keeping track of our remainders just as before. So we'll start off, and into your calculator what you need to put is 4157 divided by 16, and what you end up with is 259.8125. So it goes in 259 times. Now we need to determine a remainder. Subtract 259. Just go minus 259, and what you'll be left with is the 0.8125, and don't do anything with that. Just say times 16, and that will give you your remainder, and I got my remainder of 13. Now I'm going to divide this by 16, and again I'll just start off with 259 divided by 16, and I end up with the number 16.1875. So it goes in 16 times, and we need to know the remainder. So again, subtract the 16, and you get the 0.1825, and then say times 16, and you get the remainder 3. And finally, 16 goes into 16 one time with no remainder. And now we've got that our bottom number is smaller than our base, so we stop dividing. Now, the answer is not 10313, because 13, base 16, is this D. So what I'm going to write for my answer is 103D, base 16, is the same as 4157, base 10. Now, notice again, base 10 being smaller than base 16, you need a much smaller base 16 number to get you equal to the base 10 number. And that completes our podcast on base 8 and base 16 numbers.